our next recording. Okay, now we're going to be doing the next little part here, which is more about parabolas. Okay, but now we're going to be talking about parabolas that have shifted. In other words, they have a vertex that is not 0, 0. So this is the standard form. Remember, y minus k is a x minus h squared. However, this a is 1 over 4p, and this is the way I like to write the same thing with just my y and my k on the other side, okay? But we're still talking about the a being 1 over 4p. The only difference is now we've got a vertex that is not at 0, 0, okay? So here we have a parabola has a vertex -2, 1, and a focus -2, -1. So let's draw that situation. It's got a vertex -2, 1. It's been shifted. So -2, 1 is the vertex, and the focus is -2, -1. -2, -1 is the focus. So how is my parabola going to be drawn? If this is my vertex and this is my focus, then doesn't my parabola go down towards my focus? Okay, and what is this distance here called? We're going to call that my little p distance, aren't we? And if I was told to graph the directrix, which I would be, the directrix is going to go the same distance p above, right? Because it's on the outside of the parabola. The focus point is always on the inside of the parabola. So now, if this is a distance p, p is what? Well, it's going from 1 to -1. Distance is 2, right? So p is 2. That distance p is 2. Now, your book kind of goes into when p is negative and when p is positive. I never worry about that. I know that this parabola is going down, therefore it's going to have a negative coefficient on the front. That's all I worry about. Okay, I make it negative if it's going down, I make it positive if it's going up, and I don't worry because you know I'm a little directionally impaired anyway, so I just do it that way. Okay, so the p distance is 2, so if this is also 2, then what is the equation of that line? Okay, it went up the 1 to get here, but then it's got to go up the 2 more because the p distance goes over here, so this is going to be what? Y equals 3. Right? Y is equal to 3 is that directrix line. Okay? Now it says find the equation for the parabola, and the parabola is going to be a displaced parabola. So we've got y is 1 over 4p, right? X minus h, but we know what here's my vertex, my h is -2, so x minus -2 will be a +2, right? And then it's going to be squared, and then I'm going to have plus k, and k is 1 because it's up 1, right? So all I have to do is figure out what this 1 over 4p is. But p is 2, right? So I'm going to plug in, instead of 4p, I'm going to plug 4 times 2, which is 8. But then I know it's going downwards also, so I'm going to make it a -1 over 8. And my equation is complete. The axis of symmetry, what's that? That's the point, that's a line that goes through both the vertex and the focus, right? And what is that line? They're -2. They're both going through -2, right? So this line would not be a y line, it's going to be x equals -2, would be that axis of symmetry. Okay, everybody check out, did I get that one right? On that one was number 3 at the top of page 434, and that looks like we got that one right. Okay, now look over here to the applications. Okay, when we are talking about parabolas, there's a lot of things that yield themselves to parabolas. Now they're talking about a reflecting surface of a parabolic antenna. So they go on, I didn't write it all down, but they go on to describe that if you took an antenna, a parabola, and you spun it around, right, it would make a bowl type of a thing, in this case, an antenna. So they're saying the antenna is in the shape of a parabola. Now you'll see that antennas, okay, if it's a receiving antenna, okay, we're going to have all of these things come in, all right, so say these were satellite pictures or something like that, but they're not going to just hit the bottom, they're going to reflect up to a focal point, and all of the points on this parabola will focus in to this focal point, which is the receiver that's in the middle of the parabola. Okay, so a parabola, an antenna, is designed to have the information, whatever it is, comes straight into the bowl, right? But then it bounces, because of the parabolic shape, it bounces to this little receiver in the middle. And if the receiver is at the focus, then all of those different pieces of information are going to center right in on that focus point and be received. Okay. Now in this one, if we put our receiver too high or too low, we're not going to get good data, right? Our information is coming in and it's going to bounce to the focus point. So our receiver that we're going to receive our data with needs to be put at that focal point. Okay? And then, and ascending does the same thing. If we have a sending satellite dish that's sending data, then it's going to also basically come from a focal point, hit the bowl, and go out that way. Okay, so knowing about parabolas has a lot of applications in engineering type situations. Okay, so here we have, they've given us the shape of the parabola that when spun around makes this satellite dish or this antenna. Okay, and they're saying, where should that focus be placed so that all the data is received? Okay, so here we go. We're going to have to say, okay, 1 over 4p is that A, which is 1 over 20, right? So what is that P distance? 5. Okay, so we need to have our focal point 5 feet from, if it's all in feet, which it said it was in the problem, 5 feet from the vertex of that parabola in order for our antenna to receive the data. Okay, so 5 feet above the vertex is where it should be placed. Okay, so cool applications like that when you're dealing with antennas. Okay, now on the 68D here, I'm not really going to focus on that very much, but they are showing you the cool derivation of the parabola and the vertex and all of those things. So that's down there on the bottom. You're not really required to know that, but some, inquiring minds need to know. So that's there on page 435 if you want to know the math behind that. There it is. Okay. All right. So we are going to be going to 69 next, determinants, which we will do in a minute.